So this is about the complexity of life as an atom. First we have the atom, smallest particle of an element, and inside that atom it has an atomic nucleus, which is the center of an atom composed of protons and neutrons, and that is circled around the proton being a positively charged particle in the atomic nucleus. Neutron is the same thing but only neutrally charged. And the atomic number, which is connected to the proton by being the number of protons of the atom, gives the atom identity. The atomic weight of the atom being the mass of an atom, which is mostly just composed of protons and neutrons. So an electron is outside of the nucleus and in an electron-like cloud, and it's a subatomic negatively charged particle that lives outside the atomic nucleus. And on that electron cloud, they have the valence electron, which is the outermost electron that is gained and lost between atoms. And that is what makes up of an element, which cannot be chemically broken down and is made of one type of atom. So, electron negativity is the tendency of an atom to attract a bonding pair of electrons, which is related to the valence electrons because that's what usually is gained and lost. And that goes into an electron donor and a receptor, the donor being a molecule that easily gives up an electron, and the receptor being a molecule that readily takes up an electron. We have cation, which is a positively charged ion, and an anion, which is a negatively charged ion. And we have an ionic bond, that is a complete transfer of electrons between two atoms, and we have salt as an example, because it has sodium and chloride, and sodium being positively charged and chloride being negatively charged. Speaking of bonds, we have polar covalent bond, which is two atoms sharing electrons unequally, and a nonpolar covalent bond, which is two atoms share electrons equally. Double covalent bonds, where two pairs of electrons share between two atoms. An acid, a molecule that releases protons when dissolved in water. It gives rise, but that was connected to the anion cation, which is a hydrogen ion, which is positively charged ion because of the removal of an electron from a hydrogen atom, which is the pH, which gives into the pH, which is a concentration of hydrogen ions in a solution. And the pH is when you're testing acid and bases. An acid being a molecule that releases proton when dissolved in water, and a base that accepts a proton when dissolved in water. A hydrogen ion, hydronium ion, is form taken by a proton, H+, in an aqueous solution. Now, if we go back to the element, we have organic elements, which are composed of oxygen, carbon, hydrogen, and nitrogen, and then secondary elements, sulfur, sodium, chloride, phosphorus, potassium, and calcium. Now, hydrogen gives into molecular weight, and the Dalton being the atomic mass unit equal to the mass of a hydrogen atom, and molecular weight being the mass relative to that a hydrogen atom. So Dalton is just the unit. Now, that leads into the moles, which is in x grams of a substance, where x is the molecular weight of a substance and contains 6 times 10 to the 23rd molecules of a substance. So that is highlighted because that leads into the Avogadro's number, which is 6 times 10 to the 23rd, and allows us to relate chemical numbers of a substance to moles and atoms of a substance, which is molarity, and it's the concentration of a substance, which is moles per solute divided by volume, which equals the molarity, and the volume is usually in liters, so if it's in milliliters, you have to transfer that. And so hydrogen also leads into water, which is 2 hydrogen atoms bonded into 1 oxygen. And that is a hydrogen bond, which is the strongest of the intermolecular forces, which is found in NH, OH, or FH bonds, not carbohydroxyl bonds, carbon-hydrogen bonds. A hydrogen bond network of water, which is a bent shape, and the bent shape and the hydrogen bond that allows it to be liquid at room temperature. And we have cohesion and adhesion. Cohesion is particles that are mutually attracted and held together. Adhesion are particles that are not similar and hold on to each other. That leads into an isomer because they're talking about not similar particles, and isomers are particles with the same formula but different structures. So they're similar but not really. And that also leads into the radioactive isotope, which is a species of the same element but different masses and unstable nuclei, so they decay. And the half-life for decay is the time it takes for a species to become half of its initial value.